Hello the internet and welcome back to my channel. Today we have here on the bench a motherboard. This is another PCChips. Model is M918. Unsurprisingly, it's broken. So I got this some time ago. It was on my pile of projects for this channel and I had to go back to the eBay listing to see what's wrong with it. It says no signs of life. So it's a socket 3 motherboard, so that's for 486. Let's find a 486, some memory RAM, power supply, video card, and let's see what's wrong with it. So let's take a look at this board. It's a socket 3 motherboard, so that's for 486. It looks like a baby AT, to be honest. It feels on the small side. I'm not entirely sure, to be honest. We have 4 ISA slots, 3 PCI, 4 memory slots, 72 pins. We have an integrated hard drive controller, two serial ports, 1 parallel here. We got a battery holder here, which is damaged. I knew about that when I purchased it, so that will need to be replaced, which is not a big deal. We have some mangled jumpers here. Again, not a big deal. They just need to be straightened up. And there's no sign of a manufacturer on this board. The only thing I can find is this one here that says version 1.2a. The back of the board is fine, even though I do see some potential damage here, so I will have to check with the microscope. I would say here as well. So here there might be some broken traces which might need to be fixed. And I see that someone in the past seems to have done some repair here, so I might need to make sure that this is actually working. I'm actually impressed they put some coating on top, so this is either done by, well, a professional maybe, or I don't want to think that this is coming out from the factory, to be honest, but I don't know. I wouldn't think of finding a motherboard with some repair work and some solder mask on top. That would be the first time I'm seeing it. Now, because I couldn't really find any sign of manufacturer here on the board, I went on the retro web and I searched for, number of slots and manufacturer of the chipset, the socket, and guess what? This turns out to be another PCChips board, particularly model M918. Now, looking at the retro web page here, yes, it is a baby AT board. It's a socket 3, we know about that, and it supports up to 50 MHz FSB and up to 1 MB of cache. Now, there is a note here about fake cache. Well, it's something I have learned from my viewers, and eventually I found online lots of evidence. I don't think it applies to this board, but there have been some PC chip motherboards with fake cache. But basically these boards had fake chips and you could see the traces were not going anywhere, like plastic chips with fake metal legs soldered on something which is not going anywhere. I don't know who might have conceived this terrible plan, to be honest, but apparently that happened. Actually, for sure, because there's some videos around showing it. One is from LGR, which I'm gonna link here and in the description. It's just absolutely amazing. It really screams stupidity to me. Anyways, I do see we have cache banks here, but they look genuine, to be honest, and I don't think this is fake. But anyways, the motherboard in theory supports up to 1 MB of cache. And looking at the retro web page again, it looks like there's a clone of this board, which is an Amtron, which is another name for PCChips. Just for fun, another way to realize that this is actually the PCChips I found on the retro web page is this. There is a typo on the PCB. It says secondary. I'm not sure whether it's a typo or whether that was someone actually thinking that's how it's spelled. And if I'm looking online, it still says secondary on it. It's amazing. I love that. Oh, and by the way, unfortunately, one of the memory slots is missing. It's not broken, actually. It's only missing the metal piece, the metal clip, which is keeping the memory in place. It should be okay, but that's definitely a little disappointment, because obviously I can't really replace this one. I mean, I could from another motherboard, from a donor motherboard. Let's go in steps and let's set up the jumpers, straighten the jumpers, set up the jumpers, and then power up and see what happens. So according to the manual I found, which is for the Amtron, but again apparently these are clones of each other, I need to select the CPU speed selection. It's an AMD DX4 100 MHz, so that's going to be a 100 MHz board. I need to change these jumpers. I need then to select the AM486 DX4, which is this one, and select these jumpers. And finally select the voltage, which for the CPU is 3.3 volts, and select these jumpers here. So according to the manual, for 100 MHz operation, JP11, 1, 2, 3, 4, 5, 6, they need to be closed, and these are already closed. And JP12, it needs to be, it says 2 and 3. So obviously there's 1, 2, and 3. Which one is 2, which one is 3? It doesn't say. Well, there's no indication, but I'm assuming that this is number 1, this is 2 and 3. As all the others are, this can't be 2 and 3, so it's going to be 1, 2, 1, 2, 1, 2, and then you have 1, 2, and 3. So let's move this to the next position. There it is. Next step is the CPU selection. For JP26 has to be open. It's very difficult to see, but that's JP26, which is open. 27, 28, and 29, they need to be 2, 3 closed. So hopefully this is okay. And finally we have our voltage, and I see it's in here in red. And for 3.3 we have JP6. That's my JP6, needs to be closed, yes. And then 7, 8 and 9, which are 7, 8 and 9, they need to be in position 1, 2. Honestly, that's difficult to ascertain, I don't know. Oh well, it says 3.3 and 5 volts, so they're definitely set for 5 volts. But it's definitely a bad design. You know, there's no indication where pin 1 is. So let's move then to 3.3. I'll check the voltage before running anything anyways. Right, I got the power supply plugged in. I got some RAM as well. Let me put also a beeper, just in case, a buzzer. Actually, I'm gonna plug my diagnostic card here. Hopefully this time it's not gonna be the other way around. And also I'll plug the buzzer here, because I can't find my little one. Okay, well let's power up and let's do some measurements and see what we get. So I should be able to read something, assuming I'm on the right pin, which I'm not sure. But I'm not reading anything, I'm reading 0.1. Well, if I turn the power back on, I might get something. Okay, 3.5. 3.5 with no load is probably fine. It's probably totally fine. Okay, so I'd say let's plug the CPU and see what we're getting. Okay, well I got the CPU in, I got a PCI video card, it's connected to my monitor via VGA. In 3, 2, 1, go. Right, voltage is kind of, okay, voltage is kind of high. There is some boot codes, but it stops. Well, we got 8 beeps, and 8 beeps I'm assuming is the video card not found. So, just wondering whether, again, maybe there's some issues with the board, or I might need to put some contact cleaner where the board is. Let's do that first. And no, that didn't help. So let me try an ISA card instead. 3, 2, 1, go. Okay, no, I have the same error message, the same codes, different video card, different slots. It doesn't seem to change anything. One thing I'd like to try is what happens if I remove the RAM, because that I should get a different beep code without RAM. 3, 2, 1, go. Yeah, that's more or less what I was expecting. It's kind of a weird beep, but that's more or less the long beep you're expecting when you don't have memory. At this point, I guess it's time to have a look at those traces, because it would be very possible that there's an issue with the communication between the slots and the CPU if those traces are broken. So let's turn on the microscope and we'll take a look at those traces together. Actually, before we move to that, I'd like to do something a bit more basic. I'm removing all my boards, I'll power it up, and I'm gonna do a basic temperature check with my hand. Again, I'll fish out the thermal camera if I need later on. But no, I don't have anything obvious right now. Let's move to the microscope and let's have a look at those traces. Okay, here we are under the microscope. First thing I want to do is to check this, let's call it repair. That looks like someone has added pretty nicely, I'd say, a piece of trace here. Let's assume for now that this works, because this looks like a good job. I'm wondering who's done that, to be honest. Now let's move to the back of the board. where things are getting a bit more interesting, I think. We definitely have one broken trace here. That's damaged, but it's fine. That's the same trace, and that's it, to be honest. Thankfully, there's no further damage, so that's good. There's a scratch somewhere here. That, thankfully, is it the one I'm thinking about? Yes, that doesn't go anywhere. It doesn't... Again, it's full of scratches, but nothing shorting or damaging, to be honest. And about this corner here, again, they're scratched, but it's not broken, so that's good again. I mean, if I follow in this trace, which is the one here at the very edge, I can see it goes into here and it's basically going, it's going to the ISA slots. Well, anyways, you know, let's prepare that trace. You know, there's no good reason to do any speculations here. Now, I guess I should inspect the board for this thing, because I see quite a few of these pins. I think this is shorted actually. No, they're not. Fair enough. Not by much, I guess. Okay, well, let's start working here. I'm not gonna use the Dremel. I'll just try manually. It's just a couple of traces. And I found that this little rubber thing, it works totally fine. Just manually, as you can see. It's actually great. Now, last time I did a trace repair, I was using one of these spool of enameled copper, and some of you recommended instead of using this, I just got some, I don't know, I'm thinking about like a microphone cable which has a very fine braided shield, and use that one because that's not enameled. The enamel is not going to be in the way, refusing to solder. So let me try and grab some I think microphone cable is what I need. So I found this, yeah, it should be a microphone cable. As you can see, it has a very fine braided shield. That's definitely not enameled. And that hopefully is going to work well for my traces. Let's give it a go. I never tried that. Oh yeah, that's so much easier than using the enameled one. Oh, no. No, you went on the other one. Go away. Okay, well, now I'm going to check continuity. You can't see that from the microscope, but I'm following the trace up to the closest VIA, or VIA. There you go. We got it back. Now, I somehow don't think that that's the reason why the board didn't start, but I guess we'll have to start from somewhere. What I'm going to do now, I'm going to straighten all the pins which seems like they might be touching something else, and then we'll give it another go. Right, motherboard is in one piece, so I would say let's give it a go and see if it changes anything. 3, 2, 1, go. Maybe to AFF, it's a new code. Hey, it's booting up! Look! It was just a trace. Kind of weird, because again, it looked like it was only for the ISA slot. And fair enough, I have an ISA video card here now, but yay! We fixed it! I'm curious to see whether the PCI card now works. Okay, I've got the PCI card back in. Let's see if it posts. Powering on now. So it's the typical 8 bips for video card, but then you have like a buzzing noise and 2 beeps. I don't know what that means, to be honest. Unfortunately, I think this is the only PCI video card I have. I'm not sure. I have another PCI card to test. Is it like this video card which is not working? Shall we try another slot now? Interesting. No, it doesn't work. I mean, we know the board is working because it posts with a video with the ISA video card. So either there's something wrong with this board and I can check in a minute, I haven't used it in a while, or there's an issue with the PCI slots, which definitely I'd like to look into. I would say let's check the basics with the PCI slots. Let's make sure we have all the voltages. All voltages seem to be okay on the slot. I can read 12 volts, 5 volts, and minus 12 volts. I wasn't sure whether 3.3 volts was supposed to be there, to be honest. I even went back to another one of my motherboards to confirm. It turned out that there are two versions of PCI slots, 5 volts and 3.3 volts, and this is a 5 volts slot, so no 3.3 volts is expected. I'll show you more on this later on. And since I had my Pentium motherboard out, I also tested the PCI video card. It works totally fine, nothing wrong with it. So let's go back to the M918 and see what's wrong with the PCI slots. I'd like to check the traces of the PCI slots. Maybe there's some interruption which I didn't notice. Now, from what I see here, the PCI slots are getting the signals from this bunch of traces, which is going straight to the chipset. I've seen in the past these little legs just coming loose for just time. And again, this is also a PCChips board. I had the same exact problem on another of these boards. So I think the first thing I want to do, I just want to double check that all these legs are all securely soldered to the PCB. I mean, I'd be tempted to resolder these things, because you see what I mean? I'm not pushing a lot, but it looks like the solder is... It's probably there, but I'm not sure this should be moved at all. It feels it might do like this one. I mean, I can see it's moving. And I guess, you know, it doesn't take... You see this one? I mean, this is definitely not attached. I mean, I think if I check with my multimeter, it shows it's connected, but I mean, there's nothing completely detached, but they really don't feel like they're in a great shape in terms of bonding or binding with the trace. I think this time what I'd like to try is to do a little bit of drag soldering. Rather than using the small tip, many of you have given me some advice on that. You know, I watched the Louis Rossmann video that says, you know, don't use the small tips, just use the big one. I want to give it a go. Rather than do one by one, do a little bit of drag soldering and see if by any chance it works. If not, you know, I can still do, if it's not one by one, it's going to be pretty close to one by one. That's not good. Oh, disaster. I'm bridging everything. Absolutely bridging everything. Absolutely bridging everything. Drag soldering worked. At the beginning, obviously, I did a big mess, but then I got better. The trick is to add a tiny amount of solder on the tip, not much. If you add too much solder, it will go just everywhere. After all, those legs are already soldered and all I'm doing is to reflow them, so the extra solder won't have anywhere to go. Ideally, I think I would need one of those tips with a hoof at the tip, a small concave cavity to store the extra solder. I don't have that, but it worked anyways. It just takes a bit of time to make sure that all the blobs of solder are removed. One thing I need to check later on is inspect with maybe my magnifying lens that there isn't any solder up here where normally the microscope is very blurry. So either I check with my magnifying lens or I do a pass after it's cleaned with a different focus plane, because I've had before that everything looks good and you don't realize you have a blob of solder in between the pins, in between the legs, where you don't see it basically, and then you power up and nothing works and you're wondering why. And this is what I meant with checking the legs. So I'm holding the board at an angle. It's not easy because obviously it's not easy to remove the residues from in between the legs. If you watched my review of the Joya Lens Andon Star microscope, this is something that you simply can't do with something which is on a stand. Oh, it looks good. I would say let's give it a go, because the thing is there's another one on this board, which is this one, but this one doesn't look to be directly connected to the... This doesn't look to be directly connected to the PCI slots, so I might redo this one as well anyways. But I would say let's test the board now and see if by any chance it works with the PCI video card. Okay, everything is back together with the PCI VGA. Let's power up and see if anything changed from before. 3, 2, 1, go. Oh, okay, well now it doesn't boot up. It doesn't post at all, it doesn't do anything. Right, okay, before I burn things or whatever, let's spend a few minutes double checking those connections. I must have done something, I guess. Clearly I wasn't looking very well. Well, anyways, as you can see, unfortunately with the ring light, when there's liquid on the board, it's not easy to see things. So I'm also using my head torch here, and I was double checking like for the 5th time, and I think I might see something shiny in between the legs, which shouldn't be there. I mean, this one is liquid, it's the reflection of a liquid. This one is the same. This one I think is the reflection of some solder. See that? There's a little bridge in between these two legs. And I've inspected this, I don't know how many times to be honest. All these reflections, they just fooled me and I didn't see that. Ah, it's there. Oh yeah, it's a very, very small bridge. Okay, fair enough. Well, it's good. It's good news. I found a problem. There it is. Okay, we're back. Let's power up and let's hope it works this time. In 3, 2, 1, go. Yay! Oh. Oh, of course, I haven't got RAM, but that's good. I was testing without the RAM earlier on, I forgot just to put it back. Right, let's try again. 3, 2, 1, go. That's better. Nope. Okay, well, at least it's working. At least it's working, and it's doing the same of before. No change, so let's, well, I don't know, I'll think of something. It's kind of late in here, so I'll call it a night, and I'll resume tomorrow with a fresh mind. Okay, this is the next day. I've been thinking about the issue we've been having with the PCI video card. And first I thought, you know what, maybe I'd like to reset the BIOS using the jumper. I couldn't find the jumper, I still can't find it, but then I realized, well, there's no battery. So I guess it's unlikely that BIOS is containing any weird setting that is preventing the a PCI card from working. Then I started looking into the chipset, which is ALI, and I just googled the datasheet because I wanted to know which one of the two is looking after the PCI slots. And it turns out, as you might imagine, that the M918 is looking after the ISA slots. It's also looking after the keyboard, the real-time clock, and then it goes back and reports back to the CPU. While the 1489, it's looking after the PCI slots and also responsible for the drive controllers and also the memory modules. Now, the thing is, we know this board works, because if I plug an ISA video card, it does work. So that's kind of weird, because obviously that means that most of this board is working, the memory, this chip is obviously looking after the memory, so the memory is working. The ISA is obviously working through that chip. So it's an issue with the PCI slots, and from what I can see, the PCI slots talking to the chipset more or less directly. I would say the next step would be to find a pinout of the PCI connectors, and I guess I need to make sure that each data line and clock and more or less each one of the pins is actually going back to the ALI. I mean, there could be a broken trace somewhere or something not working, and one of the pins is not reaching the chipset, and that's why the card is not being seen. Now, there's always a possibility that for whatever reason this motherboard doesn't like my video card. Again, unfortunately, that's the only one I have. Before maybe getting another one of a complete different manufacturer, I'd like to explore all my options before I go on with something different. So I grab my multimeter and start probing and see if I can find anything. Okay, so I've been buzzing all the pins of the PCI slots, and first of all, I finally understood how this PCI connectors work in terms of voltage. The standard PCI slot is made up of 62 pins, which is more or less what we have here. As you can see here, there's a key towards the front of the motherboard. Let's say that that's the back of the computer, so that's the front of the computer. You've got key here. Now, the fact that you have a key here, that makes this slot a 5-volt slot. If the key was actually here and there was no key in here, that was a 3.3 volt slot. Now, obviously my video card matches this slot because obviously the back of the video card is at the back of the motherboard. So that makes the video card a 5-volt video card, and it won't work in a 3.3 volt slot because there will be a key here and the board is not going to work. There are actually universal PCI boards. They basically have a cutout here and a cutout here, and they basically fit whichever of the slots that you want to use, the 3.3 volts and the 5 volts. But anyways, that was the answer to my question about voltage. So as you can see, I have been marking what I couldn't basically trace down back to the chipset, which doesn't mean much, to be honest. It could be, maybe it's a voltage which is coming from the power connector, or maybe it's something else. And I printed here the pinout of the PCI slot. There's only a couple which have kind of caught my attention, and one is the clock. But to be honest, I'm assuming the clock is not going to the chipset. Probably this clock is going somewhere else. I still have to trace it. The other one is the reset line. So let's check that out. Let's plug my diagnostic card and see if by any chance the reset line doesn't work on the PCI slot, which would explain probably a board not starting up. Let's power up now. I do see the reset line flashing momentarily, so that probably already tells me that it's working. But what I'm going to do, I'm going to just basically short the reset jumper here and see what happens in 3, 2, 1, go. There you go. And the reset line is totally working on the PCI slots as well. So wherever it's coming from, I don't care too much. It just works on the PCI slots as well. The following 3 hours of footage were too long-winded, so I thought I'd do a little recap instead. I wanted to test a different PCI card on this board, but I didn't want to buy another PCI video card just for testing. So I fished out these two boards, a USB board and a Wi-Fi board. The USB board, by the way, is a universal 3.35 volts, as I mentioned before. You can see the two cuts on the PCB, which make the card compatible with both PCI versions. I figured Windows 98 would not like Wi-Fi, so I tried a USB card, but then I realized it was a USB 3 card, and I don't think I could get that to work with Windows 98, so I was back to square one. Then I realized I had an old PCI Sound Blaster Live. This is also not officially supported in MS-DOS, but I found drivers online which claim to work with MS-DOS via some emulation, so I decided to give that a go. The journey was long. First, I wanted to make sure the card would work under MS-DOS, so I fired up a working Pentium board and started experimenting. The card was detected, but it would not work. It took me some time, several tests and drivers to get to a fully working Sound Blaster Live under Doom. That was something. Well, it turned out I did not need to invest so much time in configuring the card, as when I plugged it into the M918 board, the driver failed to detect it straight away, so I did not need to do any more tests. That was my cue that there was definitely something wrong with the PCI slot, which needed further investigation. Before diving into that PCI issue, let me quickly replace the CR2032 battery holder. Thankfully, there was a modern holder in place before, so I have the required space for a replacement. This is a very simple task. Desolder the old holder, clean the flux, install the new one backwards, so I can then enjoy the process all over again, and then fit the new battery. Okay, well at this stage I guess it's time to turn on the oscilloscope and see what happens on those PCI slots. The first thing I'd like to try is the clock. which I believe, depending on the version of the PCI, should be 33 megahertz. We do have some sort of clock. Let's have a look. I only think it's only 16 megahertz. Now, I've just checked online, to be honest. I'm not an expert when it comes to that, but I think the minimum of PCI 1 is 33 megahertz, and then there's a 66 megahertz on next version, but not 16.7. Now, 16.7 happens to be, is it more or less half of 33, so I'm wondering whether this is fine and that's how it's supposed to be, but I'm not sure. So let's get a board with PCI slots and see what the clock is on that one. Right, here I got my socket 7 Soyo board. Oh no, that's 33 megahertz. Do we have a problem with clock on the other board? Okay, I'm back to the M918 and I've traced the clocks of these connectors a bit. And it looks like each one of the connector has a clock coming from a different place. They're not linked together. So clock is this pin here, and if I'm checking on the same pin on the other connector, they're actually not connected together. I'm in continuity mode, you would hear a beep. So what I found is that, for example, on this slot here, the clock is going to this capacitor C42, which is then going to ground. The clock then continues on these 3 resistors, so each one of these resistors is for each one of the slots. That's it. So I'm reading 0 ohms on this end, and I'm reading 10 ohms at the other end, because these are 10 ohms resistors, right? Okay, so slot number 2 is the middle resistor, and slot number 3 is the third resistor. Now, from this end of the resistor, it goes to this chip here, which is a 74F244, and it's an octal buffer, 3-state. So the description says the 74F244 is an octal buffer that is ideal for driving bus lines of buffer memory address registers. I need to look into that because I don't understand why we need a buffer on the clock lines. Why the clocks are not all together, I don't know, to be honest. I need to have a look. But basically, if I'm looking here, that's slot number 1 is going to this pin. Slot number 2, I think, is going to this pin. And slot number 3 is going to this pin here. So everything is coming here. And these, obviously, I guess, is getting the output of this one. Unfortunately, I can't find a datasheet of this chip, but there is a 33 megahertz coming out. So let me have a look at the datasheet of this buffer and see where these are connected. I guess there must be an input somewhere. Now, looking at this chip here, the pins that we just buzzed as connected to the clock of the connectors 14, 16 and 18. The way this chip works is very simple. It contains 8 gates. Each gate has an input and an output. The input can reach the outputs only when the output enable pin is high. Literally a gate that opens when the key is plugged in. From the schematics you can see the 8 inputs labeled I from IA0 to IB3, and the 8 outputs labeled Y from YA0 to YB3. When the OE pin, which stands for output enable, is high, then all the outputs Y receive the corresponding inputs I. The clock pin of the PCI slots are connected to pins 14, 16 and 18, which are the outputs of pins 6, 4 and 2. Let's take a look at those input pins. And I have a feeling that pin number 2 and 4 and 6, they are all connected together. So it's the same input for all 3. They go, I see there's a line going down here. There it is. It's coming to this pin here that, again, unfortunately, at the time being, I'm unable to find what this is. Well, I know it's a clock generator, but I don't have a pinout or a data sheet or anything. Let's take a look with the board on of what we are getting on those pins. So on pin number 2, which is the input of that eventually goes to one of these 3 slots through this chip, what kind of frequency am I getting? I'm getting the same, 16.7. So this buffer is working totally fine. To be honest, I wasn't thinking that was change of frequency, but you got 16.7 as an input, so obviously you got 16.7 as an output. And if I'm checking, I think it was this pin here, right? Yeah, so that's the, I'm assuming is the output of this little chip here. And as you can see, we have 16.7, which is going to the slot. So it looks like there's nothing wrong with the buffer, and 16.7 is coming from this chip. Now, I need to find a little bit more information about this chip, because again, I know I can see there is a 33 somewhere. I can't remember. I thought I saw a 33 at some point. There's a 24. Oh, there it is, 33.4. So this chip has a 33, but somehow it doesn't reach there. So it's going through this resistor. Is it going? That's my 16.7. Oh, that's 33.4. Oh, wait a minute. Did I just put the jumper in the wrong position? It looks like this jumper is selecting whether to get the 16.7, which is on this pin here, or 33, which is on that pin there. Let's go and have a look at the, well, let's call it user manual. So that's jumper 11 and 12. 11 and 12 and 18 apparently are for the speed. I have a 100 megahertz processor, so I need jumper 11 at 1, 2, 3, 4, and 5, 6. Oh yeah, pin designator should be in the closed position, so that's gonna be 1, 2, and 3 closed. Perfect. And then we got pin jumper 12 is supposed to be 2 and 3 closed. I don't see an indication of which one is 1 and which one is 2. But if I'm looking at other jumpers going in the same direction, it looks like that this is 1 and 2 and it's supposed to be 2 and 3. Oh no, don't tell me. All this time I just put the jumper in the wrong position. But why would you need 16.7? Oh, well, I guess with the different processor speed, you get different outputs and whatever. Well, let's try. I guess it's gonna work because I have 33 on the other one. Okay, well, it means it works, which is good. So that's how it should be. And if I turn it on now, I got 33 as an output. Oh no. All this time it was just me. Seriously? Well, okay, I put everything back together. Let's power up and see. But I mean, if it boots up, it's I'm gonna be ashamed for the rest of my life. But anyway, right, 3, 2, 1, go. It was me. It was the jumper. Right, okay. I would say this is the definition of overthinking or over analyzing things. And instead of going back and check the jumpers, I just assumed there was a fault and I started the oscilloscope and everything. Well, anyways, as usual, you know, I'm doing these things to learn new things. And it was nice to see, you know, to follow the signal, see how it works, see where it's going, which chip is doing what and everything. It was totally enjoyable, at least from my end. I hope you enjoyed that too. So, well, I guess at this point, hopefully, this board is fully up and running. Now, because I spent a little bit of time to set up the Sound Blaster card, I would say, let's plug it up. Let's make sure it works with the PCI video card. And let's run some games or something, make sure that everything works as expected. I tested the board with the usual stuff. All worked well and as expected. Except the sound. I could not get the Sound Blaster Live to work, no matter what I did. This is a modern PCI Sound Blaster, so MS-DOS functionalities are emulated via a driver. The driver tells me the emulation is running, but when I test the sound, I get an error message suggesting the emulation might not be working. And obviously games refuse to play any sound. I took a look in the BIOS and I couldn't find any way to reserve IRQs for legacy hardware as you would expect. After all, this is a PCI card, so not really legacy. I can only assign a specific IRQ to a specific PCI slot. I played with those settings for a while, but I did not go anywhere. Since I was committed to playing some sound out of this board, I installed my Yamaha ISA card. This is totally compatible with MS-DOS and it works fine. But guess what? Now the BIOS tells me there is a conflict with system resources. The BIOS option did not seem to help. However, I did not spend too much time troubleshooting that as... well, the sounds work fine in Doom, so I don't know, happy days. Also, when I tried booting from my old Fujitsu drive, a very old 4GB mechanical drive which works fine on other boards, the board just refused to work with it, either in manual or automatic mode. And yes, the motherboard works with a different drive. So, I don't know, I guess this is what you got back in the days when you bought a PCChip product. The last thing I'd like to do on this board is to remove the BIOS chip and extract the content so it can be put online, because the RetroWeb website doesn't really have any BIOS for this board. So number one, obviously there's nothing to upgrade, but I'd like to share the one I have here with the community in case someone ends up with one of these boards and no BIOS, for example. So the chip is a 27C010A-15, so let's find it in the programmer and extract this image. Right, here is the software, let's look for the chip. There it is. Select, and let's read it. Perfect. So the BIOS is saved. I'll send it to the RetroWeb maintainers. They can just put it online for anybody to download if they ever come up with a board like this, which either doesn't have a BIOS or is corrupted, is not working, or simply they have an older version. Well, I guess that's the end of the video. We got this working, which is good. It was kind of an easy repair. In the end, it was just a broken trace. I got a bit lost with that jumper, but I also enjoyed the troubleshooting journey, because obviously I found that there was an issue with the clock. I followed the clock and I discovered what those chips were doing, to then find that it was just a mistake in the jumper configuration. Happy days. I hope you enjoy that too. And I think this board more or less confirms how bad PCChips boards are, and that's probably why I keep finding them faulty on the market, even though this was mechanical damage, nothing wrong with the board itself. Again, I hope you enjoyed the video. If you did, I would really appreciate if you could hit the like button down below, and also consider subscribing to this channel if you like what I'm doing. For now, thank you for watching, and I hope to see you soon again here on my channel for my next video. Thank you very much. Bye bye.